Welcome to 5-Minute Math. This is Carrie Rhinehart. Today we're looking at systems of equations by elimination. If you're following along in the book, it's from Algebra 1, Unit 4, Lesson 3. In the last two lessons, I looked at solving systems graphically and by using substitution. Today I'm going to look at the last method, and that's called elimination. Sometimes it's called addition. Okay. Remember, when we're solving a system, we're trying to figure out where these two lines intersect. So I'm going to look at the same practice problem that I did both graphically and by substitution, but now I'm going to show you how to do it using elimination. All right, with elimination, what you want to do is you first want to get each equation into standard form. And if you remember, standard form is ax plus by equals c. That means we want to get the x plus or minus the y equals the constant for both equations. So I'm going to start here. Okay, to get this one into standard form, I need to move that x to the other side. So I need to subtract the 2x so that I end up with negative 2x plus y equals negative 1. And then for this one, I also need to move the x over, so I'm going to add 3x to both sides, which gives me 3x plus y equals 4. Now they're both in standard form. Once they are in standard form, we need to add these two equations together so that either the x's or the y's cancel out. So I'm going to erase this to give me some space. Erase this. All right, so now we've got the equation negative 2x plus y equals negative 1. And then we've also got this green equation, 3x plus y equals 4. And what we're going to do is we're going to add these two together so that two variables, either the x's or the y's, cancel out. But you need to make sure something's going to cancel out before you add them together. We've got negative 2x. Sorry, I did not mean to do that. We've got negative 2x. And we've got 3x. If I add those together, I would get 1x. That's not going to cancel out. We also have y plus y. That's going to give me 2y. Those will not cancel out. In order for the variables to cancel out, you have to have opposites. So it either have to be negative 2 and positive 2x, or it'd have to be negative 3x and positive 3x, or y and negative y. So to do that, we can multiply through by anything that will help us get us opposite numbers. Just make sure you do it to the whole equation. So I think the easiest thing to do here would be to get a positive 1 and a negative 1y. Well, this one's already a positive 1y on top, so I'm going to leave it. But to make this a negative 1y, I need to multiply through by negative 1. And I have to multiply the whole equation. So when I multiply through by negative 1, I end up with negative 3x minus y equals negative 4. I'm going to go ahead and bring over this negative 2x plus y equals negative 1 because I'm not doing anything to that one. And now, if we add these two together, the y's will cancel out. All right, so negative 2x plus negative 3x gives me negative 5x. Y plus negative y is going to cancel, bring down the equals, and then negative 1 plus negative 4 is negative 5. And now we solve, so divide by negative 5. I end up with x equals 1. And remember, we're trying to figure out where they cross, so we need an ordered pair. So we still need y. So go back to either of the original equations. I'm going to use this one, but you could use this as well. So I'm going to use y equals 2x minus 1. And I'm going to replace the x with 1 because that's what we just found here. So we get y equals 2 times 1 minus 1. So we end up with y equals 1 here. Therefore, our ordered pair, our answer is 1, 1 here. These will cross at 1, 1, which means this is a consistent system. All right, let's look at one more example. All right, so let's say that we're given the equations negative 2y equals negative 5x plus 10, and we're given the equation negative 10x plus 4y equals negative 20. Well, what's nice is this one right here is already in standard form, so I don't have to change anything there. But this first one, I need to add the 5x over to get this one in standard form. So that this is now 5x minus 2y equals 10. So I've got these two equations, but if I look at my x's, I've got 5x and negative 10x. Those are not opposites. And then I've got negative 2y and positive 4y. Those are not opposites either. So I'm going to have to multiply through to make one of those opposites. I'm going to make my x's opposites. I've got negative 10 here, and I've got positive 5 here. If I make this a positive 10 instead of 5, those would cancel out. In order to make that a positive 10, I need to multiply through by 2. So that would give me 10x minus 4y equals 20. And now I can bring this one down. I've got negative 10x plus 4y equals negative 20. I'm going to add these together. Well, what happens is that cancels. These end up canceling, and those end up canceling. So I end up with 0 equals 0. Remember, if the variables cancel out, it's either inconsistent or it's dependent. This is true. 0 does equal 0, so it's true. Therefore, this is a dependent system, which means these are the same line and you have infinite solutions.